Hey guys, so we are going to be getting started with our distance learning, our new information. So the first thing we're going to be starting with during week 1 is factoring. Okay, so just a quick brief overview of what this is going to look like. So if you remember before at the start, when we kind of started talking about some of this, we were given it in something called factored form. We probably didn't really call it that, but what it was we had something out here that we had to multiply into everything else. Okay, and that gave us this form here, which we called expanded form. Okay, and then expanded form was after we distributed, we would be given that final simplified answer. Okay, so again, expanded form, that has no parentheses. Okay, we used the distributive property like what I was just showing you up here in order to be able to simplify. What factored form looks like, that still has the parentheses in it. And it's actually in this unit that we're going to start to look at how we can almost get back to factored form. We're going to be doing everything opposite. We're going to go from expanded back to factored form. So that's what this entire unit is going to be focused on. How can we take something that's been expanded, been distributed, been simplified, and get it back to the way it was before we had done that? So the first thing that we are going to talk about is what is the factor? It is to write a polynomial as a product of other polynomial expressions. So you can see up here, we have a whole polynomial in expanded form. Factored form is a polynomial that is a product of other polynomial expressions. Okay, the product just means multiplication. So the first method that we're going to look at, and this is the only method we're going to look at today, is taking our GCF. Now that should be a phrase that we're used to hearing, right? And in case we don't remember, GCF stands for the greatest common factor. Okay, so the greatest common factor, obviously, which is right here, the GCF, it is the greatest term. And I say term because it can be a number, it can be a variable, it can be both. Okay, so it's the greatest term that is a factor of one or more monomials. So what does that really actually mean? What that really is saying is it is the largest or the greatest term that goes in to all of the monomials that we were given. So the first thing that we're going to focus on is just finding the GCF when we're given monomials. And if you remember, a monomial is just one term. Okay, there's no addition or subtraction involved, it's just single terms. Okay, so all of these down here that we are looking at are monomials. So the example says find the GCF of each pair of monomials. So if we look here at number 1, I want to know the greatest term, number and variable, possibly, that can go into both of these monomials. So what I always say to do first is look at the numbers and then look at any variables that are the same, like terms, okay? Any variables or bases, I should say, that are the same that we can look at. So if you start with the numbers 10 and 2, what is the largest number that goes into 10 and goes into 2? The largest number that goes into both of these is 2. Okay, there's no number that goes into 2 that's any bigger than that. The largest number that goes into 2 and 10 is 2. Okay, then we want to look at p squared and p to the third. What is the largest number, variable? In this case, it's going to be a variable or a term that goes into that. And if you remember, and I'm only going to do this in the beginning, p squared is the same as p times p. P to the third is the same as p times p times p. So how many times will they overlap? How many times do they both go in? 1, 2. So that means the largest term that I can take out of there is p squared. I can take 2 p's out, p squared. Okay, so then my final answer would just be 2p squared. That is the largest term that can come out of those two monomials. Okay, so then let's look over here at number 2. Again, we look at the numbers first. So we're looking at the numbers. Then we want to look at any variables or bases that are the same. And then if you notice, we have a b that's actually out there by itself. Okay, so we are looking to see what is the largest term or number or variable that goes in to these two monomials. So if you look at 18 and 20, what is the largest number that goes into both 18 and 20? So if you look at the factors of 18, it's 1, it's 2, 3, 6, 9, and 18. The only one that goes into 18 and 20 is 2. Then we look at our a squared and our a. What is the largest, in this case, letter variable that goes into a squared and a that I would be able to take out of both of them? I would be able to take out 1a from both of them. Right? I can take 1a out because this one's only to the first. I can't take 2 out because I don't have 2 over here. I only have 1 over here to be able to take out. Now, when I look at the b, I can't take b out because I don't have b over here. I only have b in this one, so I'm unable to take a b out and say that I can take it out of both of these monomials because it isn't located in the first one. So your final answer would just be 2a. That is the GCF. Okay, so let's go over here and let's look at number 3. Again, first thing we do, look at the numbers. And then if you notice, we have b again by itself. Is there any number other than 1? You never want to include 1 because 1 doesn't change anything. If I took 1 out of 5, it's still 5. So you have to look for a number other than 1. So is there a number that goes in between 5 and 4? Is there a number that goes into both of those? And the answer to that is no. There's no number that goes into 5 and 4. And since b is not located in both of these terms, there actually would not be a GCF. So you could write something like no GCF. I would be totally fine with that. But here, that is already as simplified as it can be. There is no greatest common factor that goes into both of those. Okay? So let's go over here to number 4. All right, now we're starting to get into a little bit bigger ones. So we have 42, we have 56. Then we also have the m's that we can match up, and we have the n's that we can match up. So if we first look at 42 and 56, you go through and you have to start thinking about what are the numbers that go into 42 that could possibly go into 56. So this is where I want you guys to go ahead, take a second, see if you can figure that out on your own. Okay, so hopefully you figured out that the largest number that goes into 42 and 56 is 14. Okay, now if you didn't get 14, you got a smaller number, you would have looked and you kind of would have wanted to make sure that you were going back and checking to make sure that that really was the largest number that goes into both of those. Okay, then now let's look at m to the third and m to the third. Both of them have 3 m's, right? That's what that exponent means, which means that if they both have 3 m's, that I can take that many out. So I can take an m to the third out. Then I look at my n's, n and n to the second. This first monomial only has 1 n, which means that is the only amount I can take. Even though there's 2 over here, I can only take 1 n out. So my final answer would be 14 m to the third n. Okay, that is the largest, that is my GCF. That is the largest term that can come out of both of these monomials. Let's go ahead and now let's look at number 5. And if at any point you want to try this and then check your answer, you can pause the video, try it on your own, and then check to see what I got to compare. So the first thing, we have 6, we have 18, and we have 12. Then we also want to look at our W's. Okay? So looking at our numbers, 6, 18, and 12. What is the largest number that goes into all 3 of those terms? And the largest number that goes into all 3 of those terms is 6. Okay, from there, we have to look at the W's. What is the largest amount of W's that I can take out? And that is 1. I can take 1 W out of there. Okay, so then your final answer would be 6W. All right, moving on to the next one. If we look at number 6, okay, first thing that we have here, we have a 7. And if you actually notice in this one, so let's actually take a step back and let's look at what we really have in this. So if you actually pay attention to this term right here, I actually haven't combined everything yet. So let's go ahead and let's do that first. So 7 times 7 is 49. T times T is T squared. U to the 7th times U is U to the 8th. And then we have V to the 7th. Okay? So those are going to be the two terms that we are focusing on. So now we can start looking at the numbers. And we can say 7 and 49. We can look at that and we can see how those work together. So the largest number that goes into both of those is 7. Okay, then we can start looking at the T's. So we have T squared and T squared. The largest number of T's that can come out of there are 2, so T squared. Then we can move on to the U's. I have U to the 2nd and I have U to the 8th. The largest number of U's that are there are 2, right? I have 2 U's here, I have 8 here. The largest amount that I can take out are 2 of them. So U to the 2nd. Then the last one are my V's. Oh, not going to use that color because you won't be able to see. So we'll just go with gray. My 2 V's. Okay, so if you look there, you will notice that you are going to end up with V to the 6th. That is the largest number you will be able to take out of that. This one has 6, that one has 7, so you'll be able to take 6 of them out. So then your final answer would be 7T squared, U squared, V to the 6th. Okay? And we have one more here that I want you guys to go ahead and give a shot on your own. And then we are going to come back together in just a second and we will go over that answer. All right. So if you want to pause because you want to still work on it on your own, you can absolutely do that. But I am going to start over this together. So we have 10, 10, 10, and 20. The largest number that goes into 10 and 20 is 10. Then we have our D's. D to the 5th, D to the 8th, D to the 5th. But if you notice, this term right here does not have a D variable, which means I cannot take out a D at any point because not all of my monomials have the variable D in them. So then that means we have to move on to our next one. We have F to the 8th, F to the 8th, F to the 2nd. But now it's this second term right here that doesn't have a variable F. So I cannot take out a term that has F in it if not all of my monomials have it. So my final answer here would actually just be 10. Okay, so if you need to go back and rewatch any of this, that's fine, but this is the first portion of our notes. There's going to be a second video right below that will have the rest of our notes that we are filling out.